$1,757. Is it behind door number 1 or door number 2 or door number 3? And before I ask you what door you want, because you're the first person I went to, I want you to know.
Okay, so this is a very interesting problem. Okay, this is what we call the Monty Hall problem. And where this problem's from is actually it's from a show. It's called Let's Make a Deal. From I don't know, maybe 1960s and 70s. And as a host, the name, it is called the Monty Hall. Okay. And typically this is how do we play the game. So you have 3 dolls, as you just see from the beginning, and then one of the doors behind that, it is a car, okay, and then behind the other 2 doors is going to be a goat, okay. So if you pick a door, and of course another key information here is Monty, the host, he knows everything. Okay, he knows everything. Suppose you choose door 1, behind that it's a car, and then Monty knows that 2 and 3 is a goat, and then he will always open a door, and that door is gonna always be a goat. Okay, gonna always be a goat. Then Monty asks you, hey, do you want to switch? Okay, do you want to switch? So this is a question. And then is it to your advantage to switch your choice? Okay, so that's a problem. They have so many different ways to explain this problem, and I'm gonna do in 2 ways. Okay, I'm gonna do in 2 ways. So this is again just to want to explain. Suppose we can list all the combinations here. Okay, so see, let's see if behind door 1, door 2, door 3. Okay. And then, so it's possible that behind door 1 there is a car. Here is a goat. Here's another goat. And then it's also possible we have a goat here. We have a car here. Right, we have a goat here, and then it's also possible that we have a goat here, we have a goat also on the second door, and then we have a car on the third. Okay, we have third. Now, let's see if you just pick door 1. Okay, if you pick door 1. Randomly pick door 1, and then if you stay with, let's say, door 1, and then in this case you're gonna have if you switch, okay, if you stay at door 1 in the first scenario, you see that you're gonna have a win, right? Okay, good. And then in the other 2 scenarios here, you're gonna go all lose and lose. Okay. While if you switch, so in this scenario you're gonna have a lose. And then in this scenario, you're going to win and win. Okay. So you see, that the winning percentage for you to switch is actually, it is higher than you stay, right? Than you stay. And then, so you see that there is one way to think about it. Okay, it's better to switch. Okay, it's better to switch. So that's one way to think about this. Okay, the other way to explain this part, we can actually use what we call the probability, okay, and then related with the conditional probability. Okay, so what we want to do is we want to know that, so the goal is find the winning probability when switch, right? When switch. Okay, so that's our goal. And let's see if I set W is the event that when, of course, it's when the car, okay? If I switch, okay. So let the CI be the event that the car is behind the door I, okay? Door I. Of course, this I can be 1, 2, 3, okay? So the probability of the car behind door I, we know that is equal to 1/3, okay? Is equal to 1/3, for sure. So how do we figure out the probability that if we switch? Okay, winning probability. So this winning probability, P of W, actually we can use the law of total to figure it out. We can think about this as the summation I equals from 1 to 3, the probability given that car is here times the probability of CI. Okay. Like we said here, if we just choose door 1, okay, this door 1, door 2, door 3, it really doesn't matter, you know. If we choose door 1 here, and then, you know, the probability of the car is behind door 1 is 1/3, right? But the conditional probability of my winning, given that the car is in door 1, you know, if I switch, do you agree that it's going to be 0? Why? Because the car is already behind the first door, and then I picked the first door, and then I asked to switch. Do you see I'm going to lose the game, right? And then plus the conditional probability of the other two Do you agree that for the other two cases here, because Monty is going to always reveal the goat, right? One of the goat here. So if the probability of the car behind C2, second door, it's also 1/3. If I switch in this situation, I'm going to definitely win. 2 and 3 is exactly the same logic here. So you see the probability of winning if switch is gonna be 2 out of 3. So in other words, it is larger than half. So for sure, yes, we need to switch. Okay. Or let's see this. Or if you switch, you have a higher chance to win. Okay. So that is the explanation of this Monty Hall problem. Okay. I hope you enjoy this video. Thanks.